We are on, that's 4-4, if yours cut off. 4-4 is called complex numbers. Half of what we're doing today is Algebra 1 review. The other half takes it like one step farther into Algebra 2. So I kind of have to go back a couple of years, even though you did it last year too. I have to go back a little bit before I can go forward, okay? So just really quickly, number 2 says the square root of negative 81. In your Algebra 1 classes, what did they say? You can't do that, right? They said that in your Algebra 1 classes, right? So that's not true anymore. We can, but you don't know why right now. So if it had said square root of 81, what would you have told me? 9, right? But it doesn't. So we'll talk about that in a second. So go to the back. You have like nothing really up here. Let's do some stuff to make sure you remember what we're doing. If I had the square root of 12, okay, call this example 1 or whatever you want to call it. I need to simplify the square root of 12 without a calculator, okay? What's the highest perfect square that goes into 12 evenly? 4. How many times does it go into it? 3. Very good. Does everybody understand that 4 times 3 is the same as 12? Right? So you pull them apart, square root of 4, square root of 3 like that. And what is the square root of 4? 2 square root of 3. So square root of 12 is the same as 2 square root of 3. Do you guys kind of remember that? Okay, you may not be great at it right now, but you've kind of done it before, right? Let's do square root of 80. Why don't you try that one? What's the highest perfect square that goes into 80 evenly? 16 is a perfect square. So yeah, 10 goes into it, right? But 10 is not a perfect square, so I don't want that one. So 16 goes into 80 how many times? 5. So you pull them apart. So it's 4 square root of 5. Do you understand that? Did anyone pull out like a 4 instead and you were left with the 20? No. Okay, never mind. Good. So let's kind of list our perfect squares. I'm not going to do all of them, but 1, 4, 9, 16, 25 would come next, 36, 49. If you start getting stuck, it's because 1 squared is 1. It's because 2 squared is 4. 3 squared is 9, right? So this is 7, so I'm on my 8 squared. 64, 9 squared, 81. 100, 121, da-da-da, right? So typically I go up to 20. Let's actually make it a little bit prettier. Let's go ahead and finish it out, I guess. 5 squared, 6 squared, 7, 8, 9, 10. Here's where you really, in Algebra 2, in Algebra 1 you had to know up to 10 squared, 100. In Algebra 2 you really need to know up to 20. It's going to be better for you. So 11 squared, anybody know what that is? 121. 12 squared? 144. 13 squared? 169. 14 squared? It's just backwards. It's 196. That's a trick to help you remember it. 15 squared. If you don't know it, take 15 squared. 225. 16 squared? Yes, pull out a calculator. 256. 17 squared? I'm actually going to put it here. I'm sorry I'm going sideways. I'll stop doing that. What's 17 squared? 281. 18 squared? 324. 19 squared? 361. And 20 squared? 400. Everybody typically knows up to here. Most people know that 12 squared is 144, right?
Wait, what do you want to write down for 17?
I don't know. Is it wrong? 14.
289.
280. Yeah, 289. Sorry. 289. Thank you. And that would be then 4. Yeah, these are right now. Sorry about that. 17 squared is 289. I must have heard it wrong. I don't know. 289. Okay. Most people know up to 12 squared is 144. 13 squared you have to memorize is 169. 14 squared is just backwards, 196. That's kind of easy, I think. I don't really have a tip for 15 squared and 16 squared, but 17, 18, and 19. What is 7 times 4? 28. What's 18 times, or excuse me, 8 times 4? 32. What's 9 times 4? Do you see that pattern? It's times a 4. Here's how you find the third number. If I'm going to do 17 times 17, 17 squared, right? I would do 7 times 7 first, and I get 49, and I get right? I get a bunch of stuff with a 9 at the end. I know the 9's at the end, right? So I got a 9 there. What's 8 times 8? 64, I'd keep the 4. What's 9 times 9? 81, I keep the 1. Those are just tricks to help you get it done faster. And then obviously 20 squared, well 2 times 2 is 4 with 2 zeros, 400. It's okay if you don't know that today, but you're going to find that the more of these you know, the quicker these are going to go. Okay? Okay. I need more room. I'm going to do some more examples. Let's see here. Let's do... No, I think we'll just go back to the front. So this square root of a negative, before today you couldn't do it, right? I is an imaginary unit, and it's the same as the square root of negative 1. So this is the same as that. Can everybody agree that that's the same as negative 1 times 81? Isn't that the same as what's above it? Right? I can pull it apart like I did before. And what's the square root of negative 1? I. So this is I. And what's the square root of 81? 9. That's weird, right? So I would actually write 9i. I'm going to say it again. What's the square root of 81? 9. This negative comes out as an I. You never have to do all that again. I don't care. I just want you to know where it came from. Is that kind of okay? Okay. I wrote all these on a new page because I just don't really have space on that one. Here's a rule that I'm going to tell you rules as we go. Okay. You have to pull out the I first. You can't work with it until you pull the I out. Okay. So don't try to shove those together and make it 6 times 24 and make them positive. You can't do that. All right. So let's pull the I's out. They both have an I in them, right? Because they both have a negative. Is everybody comfortable with that? And if you're not, please stop me. I know this is a bit intimidating, but you'll find out that it's actually really easy. Okay? Is 6 a perfect square? No. Is 24 a perfect square? No. So what I'm going to do for like 2 seconds, I'm going to ignore the I's because they're confusing, right? Okay? I'm going to pretend it's algebra 1, and this is all I'm looking at. If I can't deal with them separately, can't I just shove them together? Backwards of what we did before. Before we pulled them apart, here I'm shoving them together. Bless you. What's 6 times 24? 144. Look how pretty that is. What's the square root of 144? 12. So my square roots gave me a 12. Does everybody understand that? What's I times I? What's x times x? What's z times, what is it? I squared, right? So it's 12i squared. We're not done, don't circle it. Do you understand why we got the 12? Do you understand why we got the I squared? So here's another rule I'm going to throw at you now. You can't have anything higher than I to the 1. We have to simplify that. Okay, so let's talk about how to do that. So again, back on the back probably. Okay. We said I is square root of negative 1. That is a rule. You have to know it. There's no way around it. Okay? If I want I squared, isn't that the same as I, right, squared? Do you guys understand that? I literally wrote I squared. Okay? What happens when you square a square root? They cancel out, don't they? They go away. So it's just negative 1. I squared is negative 1. Again, the first time I do something, I show you why. After this, you can just memorize it. You're going to use I squared a bunch. So if you can memorize that it's -1, you don't ever have to show me what I just did again. I just like to show you where it came from. Okay? So I can't have I squared. It's a rule. What did we say I squared is? -1. So what's my final answer? There we go. That's it. Ask me a question. I could tell some of you are furrowing your brows. Are you sure? So in Algebra 2, it's going to happen a lot. You're going to understand some things I said right away, and some things I say you're going to need a little bit more time, or you're going to need some clarification. So if you want to stop me and ask me a question, please do so. And if not, you can wait till the end, or you can see me in win, or whatever, right? Okay, so just kind of pick up whatever you can today, okay? So this is your next one. I think it's the upper right one for you. Square root of -32. What do I have to do before I do anything else? Pull out the I. Does everybody understand that at this point? Okay. Is 32 a perfect square? Is it one we have memorized? No. You could use your calculator if you want to. It's not going to be pretty. It's not perfect. Bless you. So I have to break it down. What is the highest perfect square that goes into 32 evenly? 16. How many times? 2, right? Do you see how I'm already skipping steps? Before I showed it to you like this, but now I'm like, hey, I'm just going to go ahead and pull it apart. The first time I do it properly, I do it formally. After that, you can skip to whatever you want to, okay? So what is the square root of 16? 4, but I4 is weird, right? Like you wouldn't tell me x4, you would tell me 4x, wouldn't you? So it's 4I square root of 2. Am I allowed to have just an I to the 1? Yeah. Sam, do you have a question? Or are you okay? Okay. Well, move. Does anybody have any questions other than you just don't quite get it yet? But if you have a specific, why did you do that here? Let me know. Okay. All right. This is where it's going to get a little bit easier. All right. Pretend those are x's. Aren't all variables really the same? Right? The only reason I is different is it means something that we know. X's are just I don't know what it is yet, right? So pretend that it said 4x times -3x. What would you tell me? -12x squared. In Algebra 1, that's what you would have told me, right? So it's still -12I squared. Yeah. Oh, sorry. 4I square root of 2. Is that okay? Okay. Am I allowed to have anything higher than I to the 1? No. What is I squared? Because you're going to memorize it because it's easy. -1. Two negatives make a positive. Our answer is 12. Done. Anybody confused? Okay. Some of these are really easy. Some of them still take a while. This one, I have to do what first? Before I do anything? Take out the i's, right? 3I square root of 24 times 2I square root of 18. Have I lost anybody? Okay, great. Go back to Algebra 1. Ignore the i's for like 2 seconds. What's one thing I know I can go ahead and write down? 6I squared, right? Isn't 3 times 2, 6, right? So it's 6I squared something something, okay? Is everybody okay with that? Is 24 a perfect square? No. Is 18 a perfect square? No. We can try to shove them together and see if that's helpful. Take 24 times 18, and what is that? 432. Is that a perfect square? No. So that didn't help me a ton. From here you have 2 options. I can go ahead and break down the 432 if I'm halfway good at that, or I can just break these down and shove them back together. What do you guys want to do? Do you want to deal with the 432 or the smaller ones? The smaller ones takes longer, but it's more manageable. The bigger one takes like 2 steps, but for some of you that would take like 20 times, okay? So I might just go ahead and do both and you can pick one, all right? So I'm just going to deal with 24 right now. Go back to Algebra 1. What's the highest perfect square that goes into 24 evenly? 4 and 6. So that's 2 root 6. Is everybody okay? You try the 18. what and what? 9 and 2. So you get 3 root 2. You guys understand this is one big multiplication problem, right? So let's go ahead and simplify that. And what's that give me? 6 root 12, right? Can't I break down the square root of 12 again, though? What goes into 12? 4 and 3. The 4 turns into a 2, so I get 12 square root of 3. So this right here turned into 12 square root of 3. I'm still not done, though. I'm going to go and do it this way instead. So if it's a big number like that, I just start dividing by my perfect squares. Take 432 divided by, I don't do 1 because that's not helpful. Take 432 divided by 4. Is it pretty? It is? What's left over? 108. So I know there's probably something bigger. So you keep going until you find something that usually leaves you with hopefully a prime number. So I'm going to save some time. It's going to be 144 and 3. Take 432 divided by 144. And what is it? 3. So do you see how I got to 12 root 3 a bunch quicker? But for some of you, that number is so big that it would take you forever to figure that out. So you just have to pick a way. Does that make sense? If that's still confusing, come see me later. Okay, so now what do I have? What's 6 times 12? 72. I squared, square root of 3. Why am I not done? I squared is really -1. So I have -72 square root of 3. Done. There's multiple ways to do it. Give me a day or two and you'll figure out that you like one more than the other one. Okay? This one took us a lot longer to get there, but nobody needed my help. This one, I would divide by 4, I would divide by 9, I would divide by 16, I would divide by 25 until I got to the 144 and I realized that's what I wanted. Okay? If you've been struggling so far, here's an easy one. Pretend it said -3 plus x plus -4 minus x. What's -3 plus -4? -7. What's x plus -x? 0. So what's I plus -I? 0. So my answer is -7. That's it. You combine like terms. You add the constants, the -3 and the -4, you get -7. You add I and -I, you get 0. So it's just -7. Is that okay? Okay. This one, distribute your negative. If you don't, you get it wrong. So let's not do that. So 11 minus 8i minus 2 plus 10i. Is everybody okay with that? I just distributed my negative. Okay? Combine like terms. What's a like term with 11? The -2. So it's 11 minus 2. 9. So I've dealt with that. What's a like term with -8i? 10i. So what's -8i or -8x plus 10i or 10x? Whatever makes you feel better. Positive 2i. Am I done? Can I combine a 9 and a 2i? No? Is I to the 1 fine? Yeah, we're done. Here's another little rule I haven't said yet. Technically, if we had 9 plus 2x, isn't that the same as 2x plus 9? Those are totally fine. Either way, right? It's a little rule that I has to come in the end. It has to be, if you go back to the top of your notes, it says a plus bi. The imaginary number has to come second. So I can't have 2i plus 9. Even though you would think that commutative property of addition would still be okay, the I has to come at the end. Until like the test, I don't mark off for that because I get you don't really know it yet. But for right now, just kind of like be thinking about it. The I needs to come in the back. Tell me those 3 were easy, right? I literally want you to rewrite this one. I want you to write 3 plus 5x, and 5 minus 3x. I want to pretend it's x's for a second. Eventually, we won't do that anymore. That's not really a great idea. But for right now, just so you know that you know it, I want to do that. So go ahead and FOIL without me. You should be able to FOIL that. So you get what? 15 minus 9x plus 25x minus 15x squared. Right? And then you combine like terms in the middle. So 15 plus 16x minus 15x squared. Is that right? Let's change it back to i's. 15 plus 16i minus 15i squared. Again, after today, you're not going to do the x thing, but I just want you to know that it's the same. Bless you. What's wrong with it? I squared. Can't have it. What is I squared really? A negative 1, right? So I literally replace I squared with a negative 1. Two negatives make a positive. So I have 15 plus 16i plus 15. Combine like terms. What do I have? So 30 plus 16i. That's it. The I has to come in the back. Bless you. I'm going to pause there. Ask me some questions. Where did I lose you? What do you need me to say again? Are you sure? Okay. That is as far as we got in the other classes, so I don't want to confuse everybody. So we're going to stop here and we'll pick it up tomorrow. Okay?